All right, this is 4.1, day 2, part 2. Please write these two formulas down. They are very important. So far we've been able to convert between these two forms, but sometimes the angles are maybe not very nice. Maybe it is something like that last example where it's -3 radians, and we want to find out exactly what that is in a degree measure. So we're going to use one of these two formulas. So the purple formula is converting from a degree measure to a radian measure. So the R stands for radians. So radians equals whatever that degree measure is times the fraction pi over 180 degrees. Should be a little degree symbol there. The other one, if we want to convert from radians to degrees, we multiply the radian measure times the fraction 180 degrees over pi. Convert the following using the formulas on the previous slide, or you can use the circle that we had been working with too. If you know that pi over 4, what's the value of pi over 4 in degree measure? 45 degrees. So let's talk about question 1a. We want to convert 90 degrees to radians in terms of pi. You might know right off the top of your head what it is. You know what it is? 90 degrees as a radian measure? Pi over 2, yes. Let's use the formula to check. So I just have that formula up there for you. So number 1a, convert to radians using the formula is what we're going to do. So to find the radian measure, we take 90 degrees and multiply it by what fraction? Pi over 180 degrees. And what will happen is those degree symbols are going to cancel. And then we multiply across, and then we try and reduce that fraction. And I reduce that fraction nicely. I can reduce the numerator and denominator by 90. So I get 1 pi over 2, or pi over 2. So 90 degrees in radian measure is pi over 2. Let's talk about -60 degrees. Let's convert that one. So the radian measure is -60 degrees times pi over 180 degrees. Again, those degree symbols are going to cancel. Now we multiply across. -60 times pi over 180. What can I reduce the numerator and denominator by? By 60. So my numerator is now -pi, and my denominator is 3. Good. Last one. Actually, let's go on to a more difficult one. Let's go on to the next slide. 137.2 degrees. So now it's pretty difficult to then go and use that circle. It's not a nice number. It's not going to give you a nice pretty pi. So let's convert this to radians. So we're going to use the same fraction, 137.2 degrees, and then pi over 180 degrees. Now here's where you're going to have to use a calculator. We multiply across. So you take 137.2 times pi, which remember is about 3.14, and then divide it by 180. So what is our radian measure? Two 0.395 radians. All right. Now let's do the opposite, where we convert from a radian measure to degrees. So our formula is going to change. The only difference in this formula is now the fraction has now flip-flopped, so that our pi's will cancel. So now we want the degree measure. So we multiply the radian of pi over 5 times, and what's the fraction going to be? 180 degrees over pi. Now what's going to cancel here? The pi's will cancel. So the pi's cancel. We're left with degree measure. So now we multiply across, which is 180 degrees over 5. 180 degrees over 5 is? What is it? 36 degrees. So pi over 5 equals 36 degrees. Do you want another one of those, or are you kind of getting it? You're comfortable with the converting? Okay. All right, let's go on to complementary and supplementary. We introduced complementary and supplementary yesterday when we were dealing with degrees. Degrees, the complement we said is 90 degrees for a complement, two angles that add to 90 degrees. The only difference now is now we're in radians. So for the complement, they have to add up to pi over 2, which remember, that is 90 degrees. If we want the supplement, two angles add up to pi, which is down here, 180 degrees. So we're going to apply the same concept as yesterday's lesson.